Hey guys, welcome to your new video lesson. I just want to take a minute and give you a chance to think about the riddle for this week. If you remember, I have six sticks here. I think this might be a slightly different version from the one we saw in class, maybe a slightly easier version actually. Here we have six sticks laid out, and the idea is to add 3 sticks to get 10. Okay? So give that a try and see if you can't bring in a solution for Wednesday. Okay, let's get right to the lesson. Okay, today's lesson is about ratios and proportions. Now this should be review material for you. You should have definitely seen this in a previous math class or two. It's a really important topic, this idea of a ratio. But we're going to do a quick refresher so that we can begin to talk about what it means for two triangles to be similar. And this idea of proportion is going to be very important in that lesson. So let's quickly talk about a ratio. Now, what is a ratio? You remember one ratio we talked about, and actually thinking about the riddle that we looked at today, is pi. Pi is actually a ratio, and as you begin to think about what pi is, you might start to get a sense of what a ratio is. Now, before we define a ratio, can you think of a word that includes this root of ratio or ratio? Well, you may have seen it in this word here. To be rational, right? Or rationality. Now, what does it mean to be rational? Well, we often use this, in fact, we might say to a person that they're not being rational, right? So what does it mean to not be rational? Well, usually we would say that to a person when they're not making sense or not thinking straight, not being logical maybe, right? Or for example, if we say that a person reacts in an irrational way, it kind of seems like they might be reacting in a way that doesn't seem to fit with the circumstances, right? If someone got really angry because someone stepped on their toe, you might say, well, that's irrational anger, right? And so this actually gets to the root of this word ratio from Latin, which has to do with a comparison. And this goes back to the idea that human thinking or logic has a lot to do with comparing things, right? Being able to fit things together and being able to see their differences. And that's a really important part of rational thinking. So, in this case, we're going to be thinking about a comparison between quantities, amounts, right? So, it could be a comparison between two measurements, or a comparison between ages, or a comparison between the number of objects that I have. Yeah? So let's think of an example, right? If I have let's think about cell phones. Yeah. Here's my cell phone. It's an iPhone. Yeah. And let's say that I wanted to think about the minutes that I use on my cell phone plan. Well, I have 200 minutes on my plan. Yeah? And let's think about the amount of minutes that I spend talking to people. So let's say, for example, that I spend, in a month, I spend 100 minutes talking to Emma. And let's say that I spend 50 minutes talking to, let's say, Mr. Rumble. Yeah? So that's a really simple idea. This is a simple quantity of minutes. That's another quantity of minutes. And let's say I wanted to express a comparison between these quantities. Now, how would I do that? Well, remember, if I'm going to compare two things, it could go either way. I could compare the number of minutes that I talk to Emma versus the number of minutes that I talk to Mr. Rumble, or I could express it vice versa. Well, let's say that I want to express the number of minutes that I talk to Emma versus the number of minutes that I talk to Mr. Rumble. Well, I'm going to have to include these two quantities in order to express that comparison. So, for example, I could say that the number of minutes is 100 to 50. And another way of expressing that could be 100 over 50. Yeah? And that is a pretty simple way of comparing the two quantities. And if someone said, hey, Mr. Johnson, what's the ratio of the time you spent talking on the phone to Emma to Mr. Rumble? I could say about 100 to 50. So that's useful, but what if I wanted to simplify this a bit? Because 100 to 50 doesn't really doesn't express the relationship as powerfully as I might want to, right? As simply as I might want to. So, just like any other fraction, I could actually simplify this. Now, you might already be able to tell that this is going to be a 2 to 1 ratio, right? I can divide both sides by a common factor, which is 50, and I get 2 to 1. And I could also express that as a fraction with 2 over 1. And so if someone said, hey, Mr. J, how many minutes do you spend talking to your wife versus talking to Mr. Rumble? I could say 2 to 1. Now, why is this a better way of expressing the relationship? Well, you'll see that it's a bit more simple, and it kind of gets at the heart of it. You can tell that for every 2 minutes that I talk to Emma, I talk 1 minute to Mr. Rumble. Now, that doesn't mean that I'm talking exactly 2 minutes and exactly 1 minute. That would be very little amount of time talking to Emma in a month. But it does mean what I'm trying to get at is the comparison between the two amounts, not the actual amounts. This would be the actual amounts, but in terms of a comparison, this is a much more powerful way of expressing it. It means for every 2 minutes I speak to Emma, I speak 1 minute to Mr. Rumble. So a person would know right away that I speak double with Emma than what I do with Mr. Rumble, right? And of course this can go backwards. What if I said, for example, instead of Emma to Rumble, I said, whoa, running out of, let's try to shake this a bit. Instead of Emma to Rumble, whoa, let's go. I said Rumble to Emma. Sorry about that, guys. Let me see if I can zoom in a bit. This is actually going to be a very similar comparison, but not the same, in fact. Right? If I use the original quantities, it would be 50 over 100. And so 1 over 2, or 1 to 2. Yeah? And now, how is this any different? Well, in fact, it's like the other side. It's two sides of the same coin. If I'm comparing two things, I can express it as one to the other, or this one to the original one. Yeah? But what does that do? Well, it tells me that for every 1 minute that I talk to Mr. Rumble, I talk 2 minutes to Emma. So it's giving you more of a sense of, the focus is a bit on the first one, on how much I talk to Mr. Rumble. It's 1 for every 2. So this is giving me a sense of that I talk to Mr. Rumble half of what I talk to Emma. Yeah? So that's a ratio, and they're very, very useful for comparing quantities. Now, if we continue with this example, let's say that I talk to Emma for 100, Mr. Rumble for 50, and I talk to Mr. Semedo for 20, and I talk to let's say Miss Gonzalez for 10. Okay? Now let's think about this. Well, we already figured out that the ratio of minutes that I talk to Emma and Mr. Rumble is 2 to 1. I'm going to express it like that. Now what about the ratio that I talk to Mr. Semedo and Miss Gonzalez? Well, let's see, 20 over 10, which is going to be also 2 to 1. Now, funnily enough, even though I talk to these guys much less than I talk to these guys, the ratio is actually equal. Now, why is that? Well, remember that a ratio is actually just a comparison between two values. So when I'm just comparing these values, I'm not looking at any other values in the world. I'm just looking at the core relationship between these two amounts. And so without looking at any other numbers, or even really the numbers themselves, I want to know the relationship. And so the relationship between the amount that I talked to Mr. Semedo and the amount that I talked to Ms. Gonzalez is 2 to 1, the same as this ratio up here. So in fact, I can say yikes. Let's see if I can get, I have to shake the marker a bit, bring a new marker home. So I can say that these two ratios are actually equal. They're equal ratios, even though they use very different amounts, because they're expressing the same basic relationship. And in fact, if I brought it down, it's of course going to be 2 over 1 equals 2 over 1. Yeah? So what we say when we have two ratios that are basically equal, we will say that they are proportional. And this equation, this expression with an equal sign, is what we would say is, we would call it a proportion. Or let's say this one here, which makes a little more sense. That this here is expressing a proportion. It's saying that these two ratios, these two comparisons, are basically equal. Yeah? So let's think about it. Sorry guys about this marker. So, for example, if I had a ratio of 2 over 3, or 2 to 3, can I think of another ratio that will have the same basic relationship between the amounts? Well, how about this one? 4 over 6. Yeah? So notice that if I actually simplified 4 over 6, I would end up getting 2/3. Right? So this comparison is fundamentally equal to this one. So these are proportional. Yes. So that equal sign is true. What about something like this? How about that? Is this true? Is 1 over 3, or 1 to 3, the same ratio as 4 to 10? Actually, no. 4 to 10 is much more, if you think about it, than 1 over 3. It's very, very close to a half. So this is not actually in proportion. So we're going to put a little thing that says that they're not equal. Yeah? Now, quickly, you'll notice that, in fact, if I have an original ratio, like 2/3, as long as I take the same number and multiply the top, that same number times the top and times the bottom, I'm going to end up getting a ratio that's proportional to the original. So let's try, for example, 15 times 15, times 15. Okay? Well, let's work that out. 2 times 15 is 30. 3 times 15 is 45. So basically, we can know that 30 over 45 is basically equal to this ratio right here, 2 over 3. They're expressing the same relationship. Okay? So that's a nice little trick. I know that as long as I take the same number times the numerator and the denominator, I can find a ratio that's going to be proportional to the original. Okay? All right, one more thing. Now what if I had something like this? Yeah? So let's think a little bit about this. Here we have a ratio of 2 over 3, or 2 to 3, and we're trying to find what number is going to have the same relationship to 15 as 2 has to 3. Okay, well, we actually might be able to do this without doing any special tricks. For example, I know that 3, in order to get from 3 to 15, what would I have to do? Well, I would have to multiply this times 5. Yeah? And I know that ratios that are proportional, I can multiply the numerator and the denominator times the same number. So if I multiply the top times 5, I will get 10. And so that tells me, wow, this is killer. Let's see if I can find a piece of paper. There we go. Here we go. So what that tells me, 2 over 3 is that this ratio here is expressing the same idea as this ratio here, that they have the same relationship, those quantities. Now, what if it was something a bit more tricky? What about that? Well, that's not actually going to be as simple, right? What number has the same relationship to 23 as 1 has to 9? That's not going to be as easy. Thankfully, we have a process that's going to help us figure this out quickly. Now, if I take a proportion that I know is equal, there's going to be a special number, a special quantity that I'm going to get from multiplying the denominator of the first ratio times the numerator of the second ratio. And this is called the cross product. You must have seen this before. So 9 times x is going to be 9x. And 23 times 1 is going to be 23. In order to solve this, I'm just going to divide both sides by 9. And so x is going to be 23 over 9. And that's something that I could plug into a calculator. Let's see. Well, I don't have a calculator with me. So you can just quickly find that out. And that's going to give me some decimal. That's going to be somewhere over 2, a little over 2. Okay? Now, so that's a quick way to find this missing value in the proportion. Let's find another one. Okay, well, let's figure this out. I'm going to find the cross product, and if they are equal, the cross products should be equal as well. So 10x should be equal to 6 times 40. Okay, now let's find here 6 times 40. Well, we know that 6 times 4 is 24, and then we have another 0 in there, so we're going to get 240 equals 10x. Yeah, I'm going to divide both sides by 10. Divide by 10, that'll give me x. Divide by 10, that'll give me 24. So what this is telling me is that the ratio 6 over 10 is equal to the ratio 24 over 40. That those are expressing the same basic relationship. Okay? And I can also do that when the x is in the denominator. Let's try that out. Let's do the same problem with x in the denominator. Okay, we'll multiply those out. 10 times 24 is 240. 6 times x. And then we're just going to divide this side by 6 and this side by 6. That will give me x. And of course, this is going to give me 40. Okay, and so there I found the missing value. Now that's just a quick refresher on ratios and proportions. I'd like you guys to do a few problems, and I will tell you which ones. I'll post them along with this video. I'd like you to do check for understanding, number 3, number 4, number 5, number 6, number 8, and that's it. I want you to do those 5 problems for Wednesday. Okay, guys? I'll see you there on Wednesday, and I hope that was helpful. All right, see you guys later.